MES College Marampally, e-learning.
Good morning. Myself Sharina E.M, Assistant Professor, Department of Electronics, MES College Marampally. This lecture provides a brief look at digital signal processing, and that is one of the course in second semester MSc Electronics program. Digital signal processing is a promising technology, and that is widely used in many applications such as automotive, consumer graphics, industrial instrumentation, medical electronics, and speech and voice processing. Digital signal processing incorporates mathematics, software, and some type of hardware to manipulate analog signal. The lecture session include digital signal processing basics, how to convert analog signal to digital, the digital signal processor, a brief discussion about the digital signal processor. So, digital signal processing converts signals that naturally occurs in analog form such as sound, video, and information from sensors to digital form, and uses digital techniques to enhance and modify analog signal data for various applications. A digital signal processing system first translates a continuously varying analog signal into a series of discrete levels. This series of discrete levels follows the variation of the analog signal and resembles a staircase pattern. As illustrated for the case of a sine wave shown in figure, the process of changing the original analog signal to a stair-step approximation is accomplished by a sample and hold circuit. This stair-step approximation is quantized into a code which is of binary format, and this code represents each discrete steps on the stair-step representation, and it is accomplished by a process called analog to digital conversion. Then it is ready to be applied to digital signal processor. The incoming data is processed by digital signal processor, and some of the operations are removing the unwanted interferences, increasing the signal parameters such as amplitude, frequency, etc. Some type of encoding for secure transmission is also done. Also, correcting errors is in the transmitted code also done. All the process converts the signal to a much improved version of the original analog signal using a digital to analog converter. Then I am going to sampling theorem. Sampling theorem provides an idea about how many samples are necessary to ensure when we are preserving the information contained in the signal. If the signal contains high frequency component, we will need to sample at a high rate to avoid losing information that is in the signal. In general, to preserve full information in the signal, it is necessary to sample at twice the maximum frequency of the signal. This is known as Nyquist rate. The sampling theorem states that a signal can be exactly reproduced if it is sampled at a frequency f which is greater than the maximum frequency in the signal. The sampling process is illustrated in the figure. Analog input signal and the sampling input is given to the sampling circuit. At the output, we got sampled version of the input signal. What happens if we sample the signal at a frequency that is lower than Nyquist rate? When the signal is converted back into the continuous time signal, it will exhibit a phenomenon called aliasing. Aliasing is the presence of unwanted components in the reconstructed signal. These components were not present when the original signal was sampled. In addition, some of the frequency in the original signal lost in the reconstructed signal. Aliasing occurs because signal frequency can overlap if the sampling frequency is too low. Sometimes the highest frequency component of the signal are simply noise or do not contain any information. To prevent this aliasing of the frequency, we can filter out the components before sampling the signal. because we are filtering out high frequency component and letting low frequency component through this. It is known as low pass filter. After filtering and sampling, the sample level must be held constant until the next sample occurs. This is illustrated in figure. Analog to digital conversion is the technique of converting the output signal and sample and hold circuit to a series of binary codes, and it is actually representing the analog input at each sampling time. Output waveform that represent binary code is shown in figure. The process of converting analog value to a code is called quantization. Figure shows 4-level quantization. From the figure, we can see that quite a bit of accuracy is lost during only 2 bits to represent the sampled values. In the next figure, 16 quantization level is selected, so the accuracy is seen to be increasing. Next, the block diagram representation of a typical digital signal processing system. Here, the input signal is processed with electronic low pass filter to remove all the frequency above the Nyquist frequency. This is done to prevent aliasing during sampling and is correspondingly called anti-alias filter. On the other hand, the digital signal is passed through a digital to analog converter, and another low pass filter is said to be to the Nyquist frequency. This output filter is called reconstruction filter. Digital signal processors are typically programmed either in assembly language or in C. Programs are usually shorter than traditional microprocessor program. The DSP, unlike the general purpose microprocessor, must typically process data in real time. That is, it happens. Many applications in which digital signal processors are used cannot tolerate any noticeable delay, requiring DSP to be extremely fast. In addition to this, we can use it in cell phone, and if digital signal processors are used in multimedia computers, video recorders, CD players and disk drivers. And if we are representing all these improvement in the signal quality. Also, DSP are becoming more common in TV application. Also, there are applications in telecommunication, speech generation and recognition, radar, image processing, etc. Essentially, digital signal processor is a special type of microprocessor that utilizes data in real time. Its application mainly focus on digital data that represent analog signal. DSP, like a microprocessor, is having a central processing unit, memory unit, and in addition there is some type of interfacing function. The main peculiarity of digital signal processor is that it is using some type of specialized algorithm. So we can say that digital signal processor is the heart of digital signal processing system. Thank you.